At Researcher Lyceum, every researcher finds guidance, every idea finds strength, and every journey leads to impact.
When you have a service that offers to handle the entire research journey from A to Z, you've got to wonder, is this where academic research is headed? I mean, is that publish or perish pressure just keeps getting more intense? Are these all-in-one partnerships going to become the new normal for getting through the gauntlet? It's a pretty interesting thought for sure.
Hey there. So when you think about AI, what comes to mind? Probably a computer learning from a bunch of data, right? Well, what if I told you that's just scratching the surface, like the very, very tip of the iceberg? Today, we're going to dive deep, way beneath that surface, to explore this hidden universe of AI learning that's actually powering the world's most incredible tech. Just let that sink in for a minute. Over 20 different ways for an AI to learn. Stuff like federated, continual, causal learning. These aren't just some fancy buzzwords. For the people on the front lines, this is their daily toolkit. What you and I usually hear about, that's just level 1. These other paradigms are what researchers and engineers are using right now to tackle some truly mind-bending challenges. So what is out there beyond the basics we all know? That's the big question, right? All right, let's get into it. We're going to map out this whole fascinating landscape together. Okay, but before we jump into the really advanced stuff, we got to have a solid foundation. Let's do a super quick rundown of the 3 big pillars of machine learning that pretty much everyone in this space is familiar with. First up, you've got supervised learning. Think of this as the classic teacher-student setup. You show the AI a picture of a cat, and you tell it, hey, this is a cat. You give it the answer, the label. You do that thousands, maybe millions of times, and eventually it learns to spot a cat all by itself. Then we have unsupervised learning. This is totally different. Here, we don't give the AI any answers. We just throw a giant, messy pile of data at it and basically say, go figure it out, find something interesting. The AI then acts like a detective, It starts sorting things, grouping similar stuff together, and uncovers these hidden patterns and connections that we humans might have completely missed. And rounding out the big 3 is reinforcement learning. This is all about learning by trial and error. The perfect example is an AI learning to play a game. It tries a move. Did it work out? Great. Here's a reward point. Did it fail? Okay, that's a penalty. After doing this millions and millions of times, it starts to build a winning strategy, all focused on getting the highest score possible. All right, so that's the foundation. We're all on the same page. Now let's get to the main event. Let's explore the really cool stuff, the advanced paradigms that are blowing the doors off what we thought was possible with AI. Okay, so here's our first big real-world problem. What happens when you just don't have a lot of data? I mean, think about it. In fields like rare disease diagnosis or identifying endangered animals, you can't just download a million labeled examples. Getting that data is incredibly hard, sometimes impossible. It's a massive roadblock. And this is where things get really clever. Enter few-shot and one-shot learning. These paradigms are built for exactly this scenario. They teach a model how to make smart predictions based on just a tiny handful of examples. And in the most extreme case, one-shot learning, it can learn from a single example. For anyone working with scarce data, this isn't just helpful, it's an absolute game changer. Okay, next challenge, and this one is huge. Data privacy. Let's say you have a bunch of hospitals, right? They all want to team up to build an amazing AI model to detect cancer earlier. The potential is incredible, but there's no way they can share their patient data. It's sensitive, it's private, so how do you get them to collaborate without anyone ever seeing anyone else's data? Well, the answer is this brilliant idea called federated learning. And here's how it works. Instead of pooling the data, you send a copy of the AI model out to each hospital. Each hospital then trains that model locally on its own private data. Here's the magic part. The data itself never, ever leaves the hospital. Only the lessons learned, the little mathematical updates to the model get sent back to a central server. That central model then aggregates all those updates, getting smarter and smarter from everyone's experience, all while keeping every single piece of patient data completely private and secure. All right, here's another one. The world is always changing, right? A model you trained last year on last year's data might be totally useless today. So what do? The old way was to just throw it out and retrain a whole new model from scratch. But that's super slow, super expensive, and just inefficient. There's got to be a better way. And of course there is. It's called continual learning. This is all about creating an AI that can actually adapt and evolve. It learns from new data as it comes in, constantly updating its knowledge without, and this is the important part, without forgetting everything it learned before. This is a huge deal. It's about making AI learn more like we do, continuously. And believe me, the toolkit just keeps getting bigger and better. You've got transfer learning, which is the awesome idea that you don't have to start from zero every time. You can take the knowledge from one task and apply it to a new one. Then there's multitask learning, which is like training an AI to be a Swiss Army knife, mastering a bunch of different skills all at once. Of course, there's deep learning, the powerhouse engine with all its complex neural network layers that drives so much of modern computer vision and language. And then, oh, this is the big one, self-supervised learning. This is the secret sauce behind today's massive large language models. It's how they can learn from the insane amount of text on the internet without needing a human to label every single sentence. But maybe, just maybe, one of the most important leaps forward is something called causal learning. See, for a long time, AI has been amazing at finding correlations, noticing that when A happens, B also tends to happen. But causal learning is about understanding why. It's about figuring out that A actually causes B. And that is a monumental step towards an AI that can genuinely reason about the world, not just spot patterns. Now, I want to be really clear about something. None of this is just theory stuck in a research lab. These advanced ways of learning are out there, in the real world, right now. And they are making a huge, tangible impact in some of the most important industries on the planet. I mean, look at healthcare. Federated learning is letting hospitals collaborate on research while protecting patient privacy. In the world of finance, continual learning is crucial for fraud detection systems that have to adapt in real time to new scams. Cybersecurity uses these ideas to build defenses that evolve to counter new threats. And self-driving cars and robotics, they rely on a whole cocktail of these paradigms just to see and navigate the world. The impact is just massive, and it's growing every day. So when you see this whole universe of possibilities laid out, it becomes really clear, doesn't it? The biggest challenge for a researcher today isn't that they don't have the right tools. The challenge is figuring out which of these incredible tools is the right one for their specific problem to actually make a breakthrough. And that complexity, that need to choose the right path, is exactly why having an expert guide can make all the difference. This is where a true research partnership comes in. We're talking about support that covers the whole journey, from just brainstorming the initial concept to designing and coding the algorithms, analyzing the data, and then doing the hard work of writing the paper and getting it submitted to a top-tier journal. Because at the end of the day, success comes down to two things: being fluent in all of these different paradigms and having a proven track record of getting research published. That combination is what helps researchers cut through the noise, navigate this complex world, and produce results that actually get noticed. It really all boils down to a simple but powerful idea. The goal isn't just to deliver a project. The goal is to deliver impact. It's about taking all this incredible knowledge and turning it into something that makes a real difference, something that pushes science forward and gets shared with the world. So I want to leave you with a question to think about. Now that you've had a peek into this incredible hidden universe of AI, which one of these paradigms, which one of these powerful tools is going to be the key that unlocks your next big discovery? Something to chew on.